Hi, good morning. Day after Mother's Day. I had a wonderful Mother's Day. I hope you did too, those of you who are mothers or who still have your mother around. We're fortunate and we had a great day, so I hope you did as well. Today we're going to start on circles with 7th grade. So let's talk just a little bit about what that means. 7th grade in circles, they need to be able to do problem solving situations with using both the the formula for circumference and formula for area of a circle. So today we're going to talk about how you can look for the circumference and what it means. And we're going to do it, I'm going to assume that you don't have a ruler or a tape measure or anything else at home. So we're going to just use other materials to discover what we can about circumference. And then we'll do another session on area. So let's look at circumference first. So one thing that I'd like us to think about is the fact that in mathematics, mathematicians, some of the mathematical practices, which is how we work as mathematicians, all of us are mathematicians, remember? So, but what we want to do is provide opportunities for our students to see repeated reasoning and to make conclusions based on that repeated reasoning and patterning that they see. So we want to give them as many opportunities to see them as possible. So what I've done, I just found some things that had circles in my kitchen and the junk drawer. Everyone has one, I think. So I just took things around the house that had circles. I just put them down on the paper, made a mark, and then cut it out. So I have 4 different shapes of circles here, and you want them to be not different shapes of circles, 4 different sizes of circles, but you want them to vary a little. So I have here's one of them. I'm just going to do 3 to start with and see how we do. So we have these 3 circles, and so we want to think about what can we discover about these circles in measurement. So what are things that we could measure about a circle? So you want to ask your student that, and then just be quiet, let them answer, and let them tell you what kinds of things they're interested in about a circle. But if we ask the question, what can we measure? There's really not a lot. Well, actually, you can measure like distances between here and here. That's going to be something they'll do when they get into their geometry class. It's called a chord. And they'll be able to at sometimes measure like the degrees within a circle, so the degrees around. So if your student wants to play around with circles even more than what it takes to look at the pattern systems of circumference, let them go ahead and play with them. And actually, I cut out several circles of each of these sizes just so that you want them to play. Play is how we learn. That's Piaget's told us and taught us, and a lot of people have done work on that since then, but we know that we learn through play. So let's play a little bit with circles. So I'll start with this circle. And so what kinds of things could we measure? Well, I'm going to fold this circle in half. Now, there's a little bit of human error on this, don't forget, because we're doing an experiment, basically. So there'll be some human error on any experiment. So I'm going to fold this over. It doesn't go perfectly, but it should. So, but here's one thing we can measure. We can measure this distance all the way across. I'm going to highlight that for you. Just so you can see that. So I don't know if you can see. I don't know if you can see this here. Let me use a pencil. That would work better, wouldn't it? All right. So right about here, just in case you couldn't see that line. Here's our line right here. All right. So there's that diameter. And you can just call it a diameter. They don't have, I don't know that they'll discover the word diameter, but you can just call the word diameter. So we have the diameter of this circle. So I'm going to use for my first circle, I'm going to just use string. So I'm going to measure the distance across in string. So here's my distance across. Oops, a doodle. There. There's the distance across, which is called the diameter. So there's the diameter of that one. So we can measure that. We can also measure the radius. So if we want the radius, we're going to fold this way. Let's match up those two lines. The radius of a circle is the measurement that comes from the center out. So if you think about the radiant light of the sun, there's the sun and then it radiates out from the center. So it radiates out. So the radius for this particular circle will be from the middle out to this edge. So I'm going to mark it and then I'll cut it. Alrighty, so we have, there's the diameter, there's the radius. So now what else could we measure for this circle? And one thing we can measure is the circumference. So the circumference of a circle is the distance around the outside. So here's what I'm going to do to measure that. So I already have this mark here on this circle. I'm going to make it put a little black mark here. See it easier. All right, so we want to measure all the way around here, but we don't have a ruler. So again, one thing you could do is just ask your child, what do you think we could do? How could we measure all the way around if we don't have a ruler? So I'm going to just do it one way that I thought about. So we have this string, and I'm just going to pretend like your circle is a wheel and turn the wheel. So we need this string to be straight if we're going to do that, because if it has some bends in it, then that measurement will be too high. So I'm going to look at, if you can see over here, this spot right here. So I'm starting with the dot on the circle, and I'm just going to roll it like, it's not very easy. Roll it like a tire. Roll it like a tire. I'm going to have to check this one because this is not smooth, is it? No. Okay, let's do this one. And it's okay. It didn't work. We're playing. Okay, so I'm going to just match it up all the way around the outside. Match it up. 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 Oh, I hope I have enough string. You can see this is a little difficult to do. If you make your circles out of cardboard or cardstock, something a little bit thicker, getting the circumference will be a little bit easier. So I'm right about here. Okay, so this is my first circle. So my first circle, I have a diameter, a radius, and a circumference. Okay, so now we need to do that with however many circles you want to play with your student. So I'm just going to show you probably like one or two more just to make sure. So again, we're going to find the diameter first. So find the diameter, we're going to fold this over because it means all the way across the center. So we want it to be across the center. And the best way to do that is to fold that circle over. So here we go. We now have that diameter. I'm going to use a pipe cleaner for this one. Now I know everybody doesn't have a pipe cleaner, but just anything that you can use for what's called a linear measurement. So that just means to measure on a line. So I'm going to use this pipe cleaner, and all the way right here, there's our diameter. All right, so there's our diameter. That's like this one for that piece. Now remember what we did when we wanted to find the radius. We can fold this over. I'm going to match up these two lines here. And the radius radiates out from the center of the sun, just like the sun's rays. So we need the radius of this. Now, that's right from the center on out. Right about here. All right, now we're going to find out what the length of the circumference is. That means all the way around the outside. Let's see if we can do our wheel way this way. I don't know. Let's see. Okay, so I'm going to give it another try. It worked another time, so we'll see. So I made a little mark on my tire or wheel. I'm going to use this. Let's see if it'll work. And we roll it. Oopsie. Roll it on down until I hit that mark again. All right, so we got about here. Again, these are approximations. So we're just looking for some patterns that we're about to see. Okay, so here's our circumference of the first one, radius, and the diameter. So I'm going to do one more. I'll take this one. Again, find the diameter. Let's fold it. I'm going to use one of my favorite measuring tools, spaghetti. Put that in there. Break it off right there. There's our diameter. All right, let's look for the radius. Fold it again. See where it goes into the center. Measure. So I'm going to measure here. Snap off my spaghetti. There's the radius. So now we just need to measure the circumference. So let's make a little mark. I'm going to try the tire one again, see if that works. So let's see. So I have my mark right here. I'm going to roll my circle. So I'm going to roll it and keep it kind of going against the spaghetti. Oops, a doodle. Let's try that one again. Roll it. Again, we're going to have some measuring errors on this because we're just playing. So you have about here. All right, so now why in the world do we just do all that nonsense? So let's talk about why we're doing all of this. So here's our one circle. Here's our other circle. And here's our first one. All right, so remember when we measure, the ends have to be straight to themselves. So now we just want to look at this and see what they notice. And what do you notice is a great math question. What do you notice? That's an important math question. And remember, you want your students to tell you what they notice. Don't try to get them to notice what you want them to notice. Just ask them in an open way. What do you notice about these? So what do we notice about these? Well, your child might say one of them is a lot longer than the other one. You could say, is that true? So you want to, whenever they pose a comment that they can prove or disprove, you want them to go ahead and do that. So one could be that in all of these, there's a long one. And then there's a really short one. There's kind of a middle one. So now we say, okay, what do you notice about the relationship between all of these? So we talked about long one, middle one, short one, that's something that's similar in all three of them. But let's talk now about the relationship that they might be able to notice between the longer piece and this diameter piece. Okay, is there some sort of a relationship that they could recognize? Now you might want to start out first with the relationship between the radius and the diameter. So we know, and they might be able to just tell you this because they folded the paper, that this diameter, so if you look at this, here's the diameter. This diameter is 2 of these. Now the reason why you want them to notice that first is because you kind of want to get them into that, what is the multiplier between each of these numbers. That just means what do you multiply one by to get the other. And with the diameter and the radius, we know that there are 2 radii in every diameter for a particular circle. So we showed that on the spaghetti. Let's make sure that's true also for the pipe cleaner. So we have this pipe cleaner, that's the diameter, and then we have a radius and a radius. So that works for that circle also. Let's look at this one. So here's our radius. We have 1 radius and 2. So we've proved that that's the case. Now you might be saying, well, of course everyone knows that. Not everyone knows that. And this is a way for them to actually touch. That's called tactile. So you want them to actually touch and feel these different kinds of things. But now we know, okay, the radius or the diameter is just 2 of the radii. Okay, we can figure that out. And that it worked for all 3 of our circles. We can make that recognition or declaration. We're talking about 6th grade now. They're going to have to prove a lot of these things once they get into geometry. But we can, because we've shown just for the 3, we're going to use this idea now. So we've kind of shown it to be true. So now let's look at, because we didn't really look at the circumference for anything. So let's see if there's any kind of relationship between either the diameter or the radius and the circumference. So let's look for that. I'm going to move the string off for just a minute. Let's look for the relationship now between either, those are my dogs, Red, George, they're being noisy. So this is the circumference. Let's look and see if there's anything that looks like it's consistent. So let's just see. So we have 1, let's match that up. So we have 1, 2, 3 and a smidge. So we got 3 and a smidge for this one on the diameter. Let's look at that. Let's look at this one. So if the diameter is 3 and a smidge, what do you think the radius will be? How many of these do you think we'll get out of the circumference? I don't know. Let's check. So 1, of course I know. And you do this with your students too. You can say, I don't know. Let's check. Just saying it like that invites them into the discovery. So we have 1, 2, 3, 4, 5, and 6, and a smidge. Makes sense because we said that there were 2 radii in every diameter. All right, let's do our spaghetti. So what we're saying is that we think that about 3 and a little bit more of this diameter will be the circumference. So 1, 2, 3, and some extra. So we've shown it on those. We can show it on our string as well. It's a little bit harder. The string, because it's pliable like that, it's a little bit harder. So we have, and I have a little crook in it. 1, it should be around 3. 2, let's see if it is. Of course we know it is, but that's how we talk to our students. So yeah, 3 and a smidge. So what did we find out? We found out that the radius, the diameter, and the circumference are all related to each other. Once we find the radius, let's say it's 5 centimeters, we know, because we just proved it using our tools, we know that 2 radii is the same thing as a diameter. So we know now that that would be that. We also know, now we've just done our experiment, so just with our tools, and we're doing human experiments here. So we also know that to get from the diameter to the circumference, it's about, I'm going to use this little squiggly equals, that means about. So it's about 3 times as big as the diameter, about 3 times as big. So we know it's should be when we actually do the computation for it. So if you get a calculator out and you figure this out, then we can do that. Now, what you want to do with your students is, if you have an actual measuring tool at home, you can have them divide these things out. But if you don't have an actual ruler, which is okay, then you can still talk about circumference. We're just talking about it in approximations. And that's still healthy for your students to know. So if they know the diameter of a circle is about 20, they know that more than 3 times, a smidge more than 3 times, that's going to be the circumference. So it's okay for them to not know the exact number now. Now, many of you might already know that this number here that we're multiplying is not really just 3, it's 3.14. And that's something that you'll want your students to recognize too, is that whenever we see the relationship between the diameter and the circumference, the circumference is 3.14, or pi, that's that number pi, looks like this, or pi times d. So we can get into the details of the pi times d in the classroom, but for you and your students at home, just go ahead and make sure they understand these reasoning situations, patterns that they're finding with all the measurements with the circle. And that will serve them well. They'll be able to tell if it's about what they think it should be when they're just doing a calculation. So I hope you've enjoyed playing with circles a little bit. We're going to do area of a circle next week. So if you have some questions about area of a circle, please tune in. If you'd like to know some other ideas that you can do at home with your student without materials that are traditionally in a classroom, please send us a Facebook message or an Instagram message, and we'll be glad to cover some things that you and your students are working on. So have a great week. I've enjoyed being with you again today, and I look forward to seeing you next Math Monday. Today at 12, we're going to do equal shares, which is for grade 1. At 1, we're going to be graphing quadratics using the vertex. And then at 2, we're going to be multiplying fractions for 5th grade. So hope to see you again. Thank you.